All right, so if you haven't had a chance to finish up your Lego brick lab assignment, it's not due until next week, but try to go as far as you can with it. Try to make it a complete object. Now, one thing geometrically that I wanted to show you guys before we transition over into talking about Booleans is that I wanted to show you guys real fast how I put together mine. Turn off my texture locators. Okay, here we go. All right, so let's look at this one here real fast. Hide everything else. Now, if you look very carefully at my model, this is all 100% subdivision surfaces, okay? If I was to take off the visibility of my wireframes, it looks pretty darn good, right? The cylinders on top of the cube look really, really, really solid, right? This is where we should take advantage of that sub-D algorithm, the smoothing algorithm that puts tension across the mesh and creates a really high resolution result, okay? Now, let me show you how I put together all of my edges to get the result that we're after. Because this is the raw shape itself, okay, the unsubdivided polygons. Of course, from our earlier kind of examination of sub-Ds, if this is the original edge, we have to have one edge above and another edge loop below. And I've continued that pattern at each of the transitions between the different surfaces, okay? So I have a surface plane here that transitions over the top, so I need to have some edge loops in here to shore up the algorithm and to reduce the influence of the smoothing. Now, in the corners, I've done the exact same thing. If you think about it, I have a plane here that's transitioning to this plane over there. Well, I've added some edge loops to start locking in the algorithm and tighten everything up. And I repeat that pattern over and over and over again, even down into the insides. Now, the corners, I get these cool little diagonal jobbers, which is just fine. Okay, and I'm just using the loop slice for almost all of this to very quickly put in these new edge loops so that when I hit the tab key, everything is tightened up pretty carefully, or pretty closely, excuse me, and I get a good high quality result. The sub-D algorithm is a tool, and it's an excellent tool to produce the illusion of something that's of much higher resolution than geometrically that we actually have, right? It's an excellent tool, and I really encourage you to continue practicing it. It takes some energy. It really does. It takes some iterations. It takes some good, solid detective work at times to figure out where to put these edge loops in order to get the algorithm to behave correctly. But the guiding principle, as it always has, is that whenever we have an edge transition, okay, we need to have an edge loop, oops, here it is, above it, and then below it, okay? So an edge sandwich, going back to our conversation. It's all subdivided at the moment, but that's what it looks like unsubdivided. It looks a little strange. And this is a good illustration of what happens when the mesh is under tension, is all these edge loops start to bow and deform from the algorithm. So use sub-Ds. They really are powerful. This is going to give you the best result. I used to say a long time ago that this was the way of the future, subdivision surface modeling. It's no longer the way of the future. This is how everyone does it. So start practicing it, okay? Hold yourself to that standard, and you're going to get there. It's going to take some energy. As I jokingly said earlier, nothing comes for free in the computer graphics world. You got to put the work in. You got to start figuring out these little miniature puzzles. Okay, the principles are going to guide you to that result. Apply them. The results are going to speak for themselves. Everything's going to look good. All right, if we jump over to Canvas real fast, the Lego brick is just one part of our work this week. The second part is our house. This week, for your homework assignment, you're going to be building a house. One of my big picture goals for this class is to expose you guys to a lot of different natural applications of 3D modeling. Okay? Far too often in our world, 3D modelers get pigeonholed pretty instantly to working in the feature film world or the game world. That's no longer the case, right? There's a lot of other areas, a lot of other industries that actively use our tool set to produce the imagery that you see, for their worlds. The architectural visualization industry, this is like the duh, it's like, of course, architects are using 3D modeling to showcase their designs and their concepts and even their final finished drafted CAD work using our tool set. So today's kind of exposure is the world of architectural visualization. Building something in 3D, making a building in 3D is far easier than making a building in real life. We can move walls pretty quickly. We can experiment with color designs and different textures and patterns and for all the furnishing pretty quickly inside the computer. Very difficult to do that out there in the real world. I remember I did a job once, this was years ago now, for a client that was building out a new section of their office, and they wanted to I think they're calling it like their web hub, and they wanted all of their web designers to sit in like one area in the middle of this gigantic room. And we figured out, she had her builder draft some designs, okay? And then she gave all that stuff to me, and I made a 3D model of her entire office. It's kind of crazy. I got a lot of weird looks. I tell you what, if you ever want to get a whole bunch of raised eyebrows, start walking around with a tape measure, okay? And start measuring doors and windows and walls. People will stop you. When I first started working here, over 10 years ago now, I had the crazy idea. I was like, I want to make a 3D model of the cosmetology building, right? And I first asked the school for the architectural plans of the building, and they said no, all right? And for all the obvious reasons, they thought I was going to blow up the building or something, which clearly I wasn't going to do, right? It's crazy. It's stupid, right? So I said, fine, I'll do it the hard way. So I have a gigantic, like a 150-foot tape measure, right? And I walked around for an entire afternoon, and I measured every single door, every single window, and every single wall. And I basically by hand made a scale model of the cosmetology building. I had people stopping me saying, hey, what are you doing? You're a professor. Oh, okay, you're not going to blow up the building. It's you get a lot of weird looks when you walk around with a tape measure, but we're going to do that inside of MODO. We're lucky that our tool set's pretty advanced. We work inside of a CAD level type thinking environment. We actually have real world working scale units that we should be actively using for our modeling. Believe it or not, 3D modeling gets a lot easier when you put real dimensions behind all of our shapes, okay? I should have brought this with me today. I moved into this classroom, about a year and a half ago now, and me being me, when we made the decision that I was coming over here, what was the first thing that I did? I made a 3D model of this room. I really did. And then I threw it into Unity, and I was planning out the furniture. I made 3D models of all the desks. I'll see if I can find it and bring it with me next week. And so you guys can see this room in scale, right, with 3D desks and 3D iMacs and 3D everything. It's really easy to start understanding the spatial relationships of items when they're in scale to each other, right? We're no longer having to guess. We're no longer having to rely exclusively on our visual interpretation of these objects. We're actually using some measurements to help define that. So our conversation today is going to start exposing, the real-world measurement system inside of MODO, and it's something that we can and should be using at every single stage of our modeling pipeline. It gets a whole lot easier. Trust me, it does. We're also going to look at Booleans a little bit, because Booleans are a way for us to very quickly create some really compelling detail without a lot of energy, especially repeating details like windows. If you look inside this window, I have a bank of 3 windows on this exterior wall that are identical to each other, right? It'd be pretty difficult to slice in 3 separate windows, okay, and ensure that they're identical to each other. It's really easy for me to make one and ask the computer to automatically subtract the other 2 from the wall using Booleans. So we'll talk about the role of Booleans inside of our modeling pipeline. It's a scary kind of environment because this is absolutely kind of only you can prevent forest fires. The train can derail pretty quickly if you're not confident in what you're doing. But I think I have some great ideas that will help you figure out how to use these tools correctly to get you the results that you're after. You're going to be designing your own house this week. It can look like anything. I really don't care what your house looks like. I would encourage you to have it be your actual house, apartment complex, TP, I don't care. Whatever you're living in right now, okay? Make that, because you know that shape very directly. You know it better than anything else probably. You know every square inch of your domicile, okay? Make that place, okay? It can really look like anything. We're going to be making the exterior this week, okay? That's all we're going to be focusing on. We're not going to be doing the interior, so don't freak out. You don't have to model your kitchen sink. Although if you'd like to do that, I say thumbs up for rock and roll, man. The more detail you add, the more realistic it's going to look. But we're just going to be focusing on the exterior for this week and next week. This is going to be a 2-part assignment. So pick something that you're going to like because you're going to be living with it for the next 2 weeks, okay? This week we're going to talk all about the geometry, and then next week we're going to talk all about how to put textures on it to make the geometry come to life, okay? And it really couldn't look like anything. As you can see down here, I got some samples from some previous past student projects. What's this? Does anyone know what this is?
That's the Hobbit.
Yeah, this is bag end, which I think is kind of fun, right? Or a Hobbit hole of some kind. Does anyone recognize this house?
That's the...
Yeah, it's a Simpsons house, which I think is kind of fun, right? So it really can be anything. I really don't care what the house looks like. We're just doing a house or a building. Someone chose to do Rada South over here, which I think is absolutely fine. And he did a fantastic job of modeling the entire building. So an outhouse may be a little too simple. It could be like the Taj Mahal of outhouses. Then I'm cool, right? I'm kind of curious what the Taj Mahal of outhouses would look like. That'd be pretty fantastic. Not for this assignment. No, not for this one. You can. No, not for this class. Not for when you take GCOM 424, which I hope that you guys take next semester, then we'll talk about interiors. Yeah, and how to make the connection between the exterior and the interior. For this one, we're going to keep it pretty simple our first time out, and we're just going to focus on the exterior.
And we're not expected to do any materials or anything like that?
Just the geometry this week. Yeah, because our material process is going to look very, very different for something big like a house, right? Our entire material setup so far has been on objects. Things have been relatively small. Now we're going to be putting materials on huge scenes, so we have to talk about a different system that gets us there. Okay, and we're going to save that for next week. All right, so let's jump in and start taking a look at how we're going to work with to make our house. Okay. Now, luckily for us, the developers down at the Foundry have developed a really great tool set that's custom made for this type of work. Okay. And I want to bring to the surface a tool that I find really, really neat and very, very useful called the pen tool. Now, the pen tool inside of MODO is very different, completely different than the pen tool that you're used to seeing over in Photoshop or in Illustrator. Let me show you how it works. Okay. You can find the pen tool in this button. Now, we were working with curves last week for our goblets and glasses exercise, but if you left click and hold, here's the good old pen tool. Now, the product of the pen tool is always, always, always going to be a polygon. What's cool about the pen tool, and excuse me while I change my view to the top, what's cool about the pen tool is that I can just left click and add a point, and as I continue to left click around my scene, you can see that now I'm creating a custom shaped polygon. Okay? The ideas that we saw last week when it comes to these little control points, we saw this with our curves last week. The exact same thing is in action here for the pen tool. It's not too different, but the output is very different. We're actually getting true geometry at the outset of this action. So there's my little crazy shape. Okay? Pretty cool. It's just geometry. I got verts on here. Okay. There's a vert over here. My shape wasn't super great when I made it. There we go. Now it's rectified. So it's just geometry. Okay, let's get rid of this. Because on the surface, this isn't really all that handy. Okay. However, when we start adding in some extra features of the pen tool, it becomes very handy extraordinarily fast. I'm looking at my scene from the top. Now, once again, I'm just going to very quickly draw a random shape, something I really don't know. There we go. There's Pat's random shape. Okay. Now, I don't want a gigantic n-gon. We don't like n-gons, right? We want to have quad polygons as much as we can. Check this out. We have a great option in the pen tool called wall mode. And I really, really enjoy wall mode. With wall mode enabled, and I'm simply just going to turn its properties to inner. Let's give it a dimension. Let's make it a foot. Okay. Clearly too big. Let's do 2 inches. There we go. Look what happens. Let's make this a little bit smaller. There we go. Check it out. What's it doing? Yeah, it's making walls. Or at each one of those control points, now we're creating the illusion of maybe some sort of interior wall for our house. Let's close the shape. Okay. Now this offset amount determines the thickness of our walls. And luckily for us, there are good building codes and standards that determine the interior and exterior wall sizes. Now, I'm not a CAD engineer, but I think if I remember correctly, exterior walls, in California at least, have to be 10 inches thick. Okay? So what we could do is that if we really wanted to make a true scale model of this building or of this room, I could go in and put 10 inches in there, and now the polygons that I'm creating are dimensional. A couple things. I'm going to write this on the board so that way everyone can see what's going on. There are some number values in here that we need to be very aware of. Feet and inches are going to be the playground that we work in. Okay? So if I wanted to draw 2 feet, okay, how am I going to do it? How do I mark an indication of a foot? Yeah, you got it. So 1 apostrophe, or just apostrophe, is a foot. Okay. Now 2 inches is that. Okay. Close quote. Okay, or just a quote. Okay. So this is feet. This is inches. Okay. So over here inside of MODO, if I wanted to go in and make that my offset value 10 inches, it would look something like this. 10 inches. Okay. Hit return key and whew, I have some work I need to do. I have a lot of work that I have to do. I'm going to redraw this here in a minute because this is just kind of madness, just to kind of illustrate the idea. I think all my verts are crossed. There we go. Yeah, I'll redraw this at the appropriate size because that's just kind of crazy. So 10 inches. There we go. Voila. Pretty cool, huh? Pretty cool. Now, while we're here and while we're looking at it, the tool is still live. We have a couple different options in this wall mode. Now, notice we have a control point right here. When the mode is set to enter, the control point's on the interior of the house, and the wall and the little ray that comes out of the vert extends to the exterior. We can flip that if we want. Now the control point's on the exterior, and it's 10 inches in from that point. Okay? Or we could do both sides. How big is our wall now? 20 inches. Okay? I'm not sure why we have that both, but it's there for a reason. I don't think I've ever used both. I'm an any guy for the most part. So I usually have my wall mode set to enter. That way I can very quickly figure out what, where all these points need to be. Now, last time I checked, architects are really into like 90-degree angles. Okay? Straight lines, 90-degree angles. It's usually something that architects and people that are engineers, they're really about that, right? Except maybe the folks that made the art building. You can see that all the walls are crooked, right? I don't think they had a level when they made that building. All the walls are at odd angles. I'm joking. I love the art building. It's a wonderful space. That's the low-hanging fruit joke. I had to make that joke, right? Yeah.
My wall mode's not showing anything.
Okay, so a couple things. If your wall mode isn't showing something, remember, you got to have an offset value, okay? If that offset value is 0, it's just going to show up as dots. In addition, if your wall value is 10 inches, okay? Excuse me. Okay, now if you're way zoomed out and you go into the pen tool and do this and put 10 inches inside and you get that, why is it not like super big right now? Let me turn on the grid so you guys can see what's going on. Okay. It's so far out. Remember, we're working in a real world kind of unit of measurement here, right? My walls are 10 inches. Right now, how big are each one of these grid squares? 50 miles, okay? And we know that by looking in the lower right-hand corner of our OpenGL viewport. This right there says 50 miles, okay? So we got to keep that in mind. We are working in a real-world environment that understands scale and proportion in these dimensions very, very accurately. I ran a test. Yeah, it's so far out that we can't even see it. I ran a test, this is a while ago. Someone asked, is our world in MODO truly infinite? And I went, oh, I think it is. I've been told that it is. Let's test it, right? So I went onto the internet and I found the actual distances between all of the planets in our solar system. and I found the actual, the dimensions of all the planets in our solar system, and I made a scale model pretty quickly. It's pretty easy. It's only like 9 spheres. It's not that big. Not that bad. But I made a scale model of our solar system in MODO, and guess what? MODO did it. I could, I had my sun at the origin, and I flew out to Pluto in about a heartbeat, and it worked, right? So as far as I know, at the very least, the boundaries of MODO represent the boundaries of our local solar system. So beyond that, I really do believe it's an infinite environment. So keep that in mind. We are working in real scale units. One thing, now this is something that you should be mindful of coming in and out of all of our labs here on campus. People often change their unit of measurement. Okay, I've gone into my global MODO preferences, which you can find up here. Okay. And then under the units section, which is way down here at the bottom, the input, units, okay, at the top of this form is where we can change our unit of measurement. Right now I'm in good old English. They should just say American here. It's like us in like one other country, like small country in 2 other countries in Africa. Yeah, it's nuts. Right? Yeah. I saw a great meme the other day when the government shut down. Do you guys remember that? This is about, what, 3 or 4 months ago? The government shut down for exactly like 8 hours, right?
Oh, yeah, people were shivering. Oh, no, the government.
It's going to shut down. It's going to be horrible. Yeah, they were shut down for like exactly 8 hours. And someone posted on my Facebook feed this great meme. It's like, quick, the government shut down. Let's change everything to metric, right? Because metric is far better. It's so much better than feet and inches. But at times you'll find, especially over in the lab, that your unit system is going to be the better one, which is metric. But in good old America, we've got to be in English, which is feet and inches, which doesn't make any sense, but it is what it is. All right, let's get to work. Since we're used to seeing feet and inches, I want to keep my measurement system in feet and inches, and let's get to work. So I mentioned earlier that architects and building designers, we want to have like straight angles, or 90-degree angles and straight lines and real consistent shapes. Well, at the moment, our pen tool doesn't really behave in that world. I get to go in and define the location of all these control points, which is going to determine the size and the placement of my walls. Okay? Well, what if I want to have like this surface here and this surface here be a 90-degree corner? Okay? How can I do that quickly? I don't want to have to go in and like measure and just like align things. That's a lot of work. I mean, that's a lot of work. I have a gigantic thinking machine sitting in front of me. I want to let it do the hard work. I want to expose to you guys probably one of the best features of MODO, and that's the snapping system. Okay? The snapping system inside of MODO is a global snap system. So once we turn it on, it's going to influence literally every single tool inside of our ecosystem, which is pretty rad. You can find the snap system way up here. Okay? This is a toggle. When you press the button, it enables it. You press it again, it turns the snap system on and off. The keyboard shortcut is X. X is an X-ray. Okay? This turns your snapping system on and off. Now, when it's on or off, we can go in and tell the computer what to snap to. We get access to that snapping, our snapping options a couple different ways. The easiest way is just hold down the Option or the Alt key. We can get all of our snap options. Okay? So right now, we're doing vertex snapping. So we'll snap to verts, to other verts inside of our three-dimensional scene. But if you keep cruising down this form here, look at what we're able to snap to. Check it out. World axis snap, okay? Straight line snaps, I like that. Right angle snap. There's some good stuff in here that will allow us to snap to other, kind of global elements pretty fast, okay? I want to turn on these bottom 3. I'll turn off vertex and then simply hit the X key to enable my snapping system. So world axis, straight line, and right angle. Let's turn on our global snap. And note that my pen tool is still on. And now, when I start moving these things around, see the little purple, it's impossible for me. Let's see if I can do it. I gotta do 8 things at once here. Is it gonna work? No, it's not gonna work when I'm all zoomed in. Oops, that was horrific. But as I start to move these things around, check it out. Now I'm getting the straight line snap right there. There's a small, faint little purple line that showed up. Let's see if I can do it. You see in the boundary over there on the right, or excuse me, over on the left, what's that little square in the corner mean? It's a 90-degree angle. So we're actually getting true indicators from good old geometry class of how all these surfaces are working together. We're also getting a preview. See that little line showing up? I just had it. See the little purple line showing up in the OpenGL viewport? That's telling me that if I was to put my vert there, it's going to be either a 90 degrees or a straight line to another vert. So we're getting some really good feedback here from the computer that's allowing me to go in and very quickly make like some 90-degree corners. Okay? Like there it is. Now I have a 90-degree corner in that edge. Okay? Let's see. Let's start planning a house here. There we go. This is looking cool. This is going to be my back door. All the modern houses have these crazy, like, odd angles. Need one more vert in here. There we go. All right. Oops. I messed it up a little bit. Actually, you know what? Oops. Went back too far. Let me drop the tool. Rebuild that real fast. Sorry. My MODO is acting odd. Okay, let's try this again. Now I got my snap in there. I'm going to keep this real simple. Something like that. There we go. That'll be fun, right? This will be the front door over here. Have a nice little bay window looking out into my porch. Of course, I gotta have like some, I gotta have a barbecue area in the back because I love barbecuing, right? This is where my back door is gonna be. Maybe a couple windows looking out. This is gonna be Pat's awesome modeling hut. That's what we're gonna make today. Yeah, this is gonna be my my man cave, right? I wish I had a man cave. I don't have a man cave, right? I have 0% of my house that's a man cave. Yeah. Every time I try to step a little bit, my wife comes in, no, you're not having Star Wars stuff out. And I go, all right. Yeah, that's very true. All right. Anyway, so this is looking pretty good. So what I've created here is the floor plan. Okay? Now, once I drop the tool, I just have true polygons that I now can start beveling or extruding and doing whatever I want, right? I've also made this at scale, so I know that each one of my walls is the exact same dimensions. They're 10 inches wide. Okay? Now, what about the total area here? How big is Pat's modeling hut? I don't know. Let's find out. We have a really great tool under the View pull-down menus at the very bottom called the Dimensions tool. Okay? And the Dimensions tool is just going to simply measure some stuff for us. Okay? There it is. I can see that Pat's modeling hut is 20 feet 6 inches along the z-axis and 22 feet and change along the x-axis. Okay? So I get some really great dimensions. This is also going to show us dimensions on a selection. So if I wanted to see exactly how big that wall was, now it's 10 inches, excuse me, 10 inches wide by 22. So it's going to change based off of what this wall here is 11 feet 4 inches, which is pretty neat. So we're going to get some really great feedback. If you wanted to really geek out about it, if you wanted to get like the interior angle here, we also have a ruler tool. Now the ruler tool works best when it's paired with some vertex snapping, so I'm going to turn off all this other stuff. Okay? And this little cross here can be snapped to an existing vert. There it is. So 24 feet diagonally across the house. So we have some really good measurement tools inside of MODO that will allow us to get the accuracy that we're looking for. Okay? I want to turn my snapping engine off and disable my ruler tool and get to work, because I have a couple things in here that I need to produce in order for Pat's modeling hut to come to life. Okay? This is just the floor plan. This is the exterior elevation, if you will, of our house. So I need to raise the walls up and start getting some actual dimensions. Okay? I don't want it to be just a floor plan. I want it to be, a three-dimensional house. The pen tool is always, always, always going to produce polygons for us. So how could I physically start to grow my walls from my simple little floor plan? Yeah, extrude's going to work, bevel's going to work, either 6 to 1, half a dozen to another. If I run the extrude tool, check it out. Have you guys ever noticed that over inside of our tool properties, we have real dimensions in here? I could, if I wanted to, I could say I want my walls to be 12 feet high, right? Let's just do it real fast. 12 feet, hit the return key. Now I know with great accuracy that those are 12-foot high walls. Okay? And I can see that maybe Pat's model and hut is a little small. That's fine. I don't have a very big house or a big backyard, so this is probably appropriate. It's probably all I have room for in my tiny backyard. Okay? So this is going to work just fine for me. Okay? All right, so now I'm continuing to use our real-world system of measurement to aid my modeling process. This is great when you're working with an architect or with actual plans because we can start putting some measurements in. Okay? We're no longer exclusively using our eyes. All right. So this is starting to look pretty great. But we need some windows in here. We need a lot of windows in here. Okay? Now, I want to have a whole bunch of windows because Pat's model and hut, it's going to be, I like to let the natural light in. Okay? So I want to have a lot of windows. I want to have all the windows be a very similar shape and size if possible. Okay? I could go in, and start slicing this, but that's going to be a pain in the butt, right? Let's pretend I want to have a window over here, maybe a couple on that wall, a big one in the back, a couple on this wall and on that wall. Okay? Now I want to do the windows for the outside and the inside. I want the windows to go all the way through my walls. Given what we know about MODO so far, how are we going to do this? You can slice it. Our slicing tools would come in play here, right? Especially if maybe loop slice would be good, okay? Because loop slice would allow us to very quickly define the tops and the bottoms of the windows, okay? Maybe that, oops, let me turn my wireframes back on. So that loop right there is going to be the tops of my windows. I don't want my windows to go all the way down to the floor, so maybe I just raise this loop up. And now I've defined the tops and the bottoms of all the windows. That's cool. But how can I establish a consistent width for all of my windows? That's a problem, isn't it, right? It's a huge problem. Because I could go in and kind of do it by eye. I don't like by eye, I would like a little bit of accuracy in here, and maybe some real-world units will help me, or maybe my designer friends figure out how big or how small my windows are going to be. So our slicing system breaks down pretty quickly when we're trying to do a repeating element like we're doing here, right? One window that's the exact same size on all the walls going around our house, okay? So let's delete this, and we'd have to do the inside as well. I have to slice the inside, and it would have to be perfectly aligned to the location of the slices on the outside of the house, right? Problems, problems, problems using our existing slice tool set. So let's get rid of those real fast and start talking about Booleans. Booleans are going to allow us to use existing geometry as slicing guides, okay? Think of them kind of like really glorified fancy cookie cutters, okay? What we have here in our walls are the raw cookie dough. And we're going to take this cookie cutter and zoom, subtract the middle from our cookie cutter. Okay? The first thing that we need to do is that we need to physically create the cookie cutter. We already have the cookie dough ready to go. It's all perfect. I love cookies, by the way. This is a horrible time of year for me, right? Horrible time. This is the worst, right? The holidays, I love every single thing that comes out during the holidays. Like you go into Trader Joe's, like literally everything is pumpkin related to Trader Joe's right now, right? Yeah, and I love pumpkin stuff. The sweets are pretty amazing. Okay, so I need different metaphors than cookie metaphors. Okay, anyways, so let's go in and we're going to create some geometry here. Now this piece of geometry is going to be our cookie cutter. We're just going to create a cube. Now how big is our window going to be? Now, I've just drawn a two-dimensional cube using the cube tool, okay? But luckily for us, since we're talking about scale, and we have a little bit of experience with scale, we can go over and use these channels here to actually physically create, like, I don't know, like a 3-foot by 4-foot window or something like that, right? Let's just do it real fast, see how big it is. So we want it to be 3 feet, oops, that's 3 inches, 3 feet by 4 feet. There we go. And there it is. There's my little 3-foot by 4-foot window. That's pretty small. It's teeny tiny, actually, given my 12-foot window height. So maybe it needs to be 4 feet by 5 feet. Yeah, that's better. Or any version of that so far, okay? Now, all I really care about initially is the dimensions of my window along the X and the Y, okay? These are the dimensions in here that I'm most concerned about. We do need to make it a 3-dimensional shape, but the size of our window along the Z-axis is arbitrary. All we need to create here is a shape, a cookie cutter, that's going to extend through our walls like this. Okay? And this is the part that a lot of folks miss. Okay? It's got to go all the way through our walls. Okay? Like this. That way, when we tell the computer to use our cookie cutter to slice our mesh, it slices the outside wall and the inside wall simultaneously. And we know that they're going to be in perfect location to each other. All right, so I want to have this window in the middle of that polygon. Now, we actually talked about this before. Does anyone remember how to do this quickly? How to start centering 2 different shapes to each other away from the origin? The work plane. The work plane is going to be our guy. So I want to have that polygon selected, and probably realistically, I probably should have that polygon, the inside one, selected. Yeah, because the outside wall, it's bigger than the inside wall. So I want to have the inside polygon selected, and then align my work plane to my currently selected polygon. And now I just grab my window and perform center selected. Oof, now I know beyond any reasonable doubt that my window is perfectly centered in the wall. I don't like its height vertically, so I'm just going to move it up. But I'm going to work really hard not to move it along the X and the Z. And there we go. Awesome. Looking pretty good. Now I need some more. Okay. I want to have this window, the window on this wall and the windows on this wall be the exact same size. Okay. So this is one of the cool things about working inside of MODO. I'm just going to make a copy of it. I'll rotate it 90 degrees. And now I'm up and running. Now I could absolutely go in and really center these things. Shoot, let's just do it real fast. Sometimes I hate being me. Now I want to center these along the ZX. There we go. We maintain the height, and now they're centered along in the wall itself. Cool. So now these 3 windows are the exact same size, and they're in the exact same location up and down along the y-axis. Okay? So we're going to be using geometry to slice geometry. The cookie cutters can cross themselves as they are over here. That's fine. The Boolean operator doesn't care, but they do need to cross through the exterior walls. Let's just do, I'll do the door later. If we have time, we'll do the door, but I got to have a big window in the back. Gotta have it. Gotta have a big window. Like to see the birds. There we go. Big bay window. Maybe I'll have a door over here that leads me out onto my small little back patio. Right? Pretty cool. All right. This is not my retirement home. It'd be really small if this is my retirement home. This is like one of those tiny houses they have, right? Have you guys seen those? It's like you too could live in 150 square feet. I'm not, I really, really don't want to have to do that. That's funny. Yeah, right? This is a really fancy doghouse. Okay. So there's all my windows. I'm really happy with what I've created. The second part with working with Booleans, once you have all the cookie cutters created, is that we have to start putting them on their own mesh. Okay? So we got to start separating these items out from one another. And luckily for us, it's really easy. I'm just going to go grab all of my windows. Oops, I grabbed my walls on accident. There we go. And I'm going to cut and then go to an empty mesh item and simply paste it in. Right now I have the visibility of the inactive mesh items to match the same as my foreground. I usually turn this button off. It's a viewport property, that's all it is. Okay? In essence, that last button is going into your viewport properties, and under the active meshes section is just turning that section off. Okay? I usually like to have it off because it shows me pretty quickly what all of this stuff over here is looking like, and which polygons are associated and assigned to which mesh item. So this is the wall. And I'm just going to put this one as cutter. All right, so we want to have all of our cookie cutters on their own mesh item. Once our cookie cutters are saved on their own mesh item, we can return to our walls. Ta-da! Okay. Kind of get a good spot check on what's going on here. And next, simply we just go and run the Booleans. You can find the Boolean tools under the geometry pull-down menu. There's 3 of them. There's axis drill, solid drill, and Boolean. I want to look at solid drill because solid drill gives us the most options going forward, right? It puts us in the driver's seat. It basically allows us to figure out what step 2 is going to be. Okay? I hate it when the computer takes over and removes me from the decision-making process. The solid drill operator I really like because once we fire it off, this operation determines the output of the command itself. So I want to do slice, okay? Because I want the computer to use that background geometry, all of that, the windows, the cookie cutters that I just made, and I want the computer to slice my walls from there. Okay, it's a great, almost kind of non-destructive way of ensuring that the background mesh items are not going to permanently destroy your foreground shape. Then once we hit OK, bloop, ta-da, we can actually start to see exactly what is done here. If you look closely at my walls, you can see that the computer has gone in and sliced my walls to match the shape of my cookie cutters. Okay? I'm going to turn off my cookie cutter mesh item for a second, and which will allow us to quickly see what's going on here. Let's turn off my cutters. Mission accomplished. Things are looking pretty good. Now don't worry about these little edges. Okay? This is the computer trying to solve the surface. It has to, it basically created a gigantic n-gon in here, and it's trying to normalize the surface to an existing edge, so it automatically places that diagonal edge in there. That's okay. That's fine. We can live with it for the time being, right? If you have the energy and the time and the wherewithal, you can go in and continue to slice this into quads, which will remove that edge in the sequence itself. So now I'm in the driver's seat. I've sliced my walls, but how am I physically going to create the opening for the windows?
You have to select both polygons on both sides.
I like it. You could delete them, absolutely. Grab the inside one or the outside one, the inside one, delete them. But we're left with this.
Yeah, you got the but you can bridge that.
You can bridge it, yeah, absolutely. I think we even did this for our train. Bridge, click, and now we have geometry for our little windowsill. That's pretty neat. Here's another great little trick. Grab the outside polygon, the inside polygon, just run bridge. Does the work for you.
You remove polygons.
Nope, it removes them for me automatically. So I can just very quickly go around Pat's modeling hut, bridge the windows. You can't do them all at one time, which is unfortunate. But luckily it doesn't take much energy. And now it's starting to look like a house. Okay? And all the windows, except my big bay window over here, are the exact same size and in the exact same location inside of our three-dimensional scene. Booleans are rad. We can cut any piece of geometry with another piece of geometry using Booleans. And it really could be literally anything. Let me prove it to you, okay? And this is where it gets crazy and a whole lot of fun. I'm going to add in a new mesh item, good old Teapot. And I'm going to have a teapot shape. This is going to be like the Roadrunner cartoons, right? Or like when Bugs Bunny like runs through a wall, you have like a bunny-shaped, opening in the wall. We're going to have a teapot-shaped opening in our wall. Okay, this is going to be funny. Right? As long as it goes through the mesh, we'll be okay. I'm going to make it really big. That way. There we go. Okay, I have no idea if this is going to work, but let's roll with it. Let's see what happens. This will be strange. Okay, let's go back to my walls. This is going to be not awesome, but oh well. We'll run Boolean solid drill. The operation will be slice. Let's turn off our teapot, and there it is. There's my teapot slice inside the wall. Okay, and I certainly could try. This is going to fail so miserably, but I could very quickly start to. Yeah, that's not fun. This is a great example of just because you can do it doesn't mean you should do it, right? The tools are pretty simple, and if you give it a really complex scenario, the tools are likely to kind of blow apart on you. You can get dangerous pretty quickly, or it can get dangerous pretty quickly, because the tools, there's no context to the tools. They're just going to slice whatever's in its path. So be careful with it. Only you can prevent forest fires, okay? Know where your geometry is and know what you're slicing, okay? That way you don't get big boo-boos like I have here, because this is if you guys came to me with this problem next week and said, how do I fix this? I'd go, start over. That's how you fix this, okay? Because there's no way to fix this problem. Let's go back in time. I don't want a teapot window in my house. But I do want to have maybe a roof, okay? Maybe a roof, yeah, because if you look at my house from the front, Pat's modeling hut's starting to look pretty badass, but, it rains from time to time, okay? And I certainly don't want like a bird to fly in, right? So I got to have a roof on this thing. When we're doing any type of modeling, we always want to start with a basic shape deconstruction. What basic shape is a roof? Ish? Yeah, triangle-ish. What materials do they build a roof out of? I spent an entire summer as a roofer when I was in college. It was the worst summer of my life. I knew pretty quickly that I was not put on this planet to be a roofer, right? I hated being a roofer. That was just not fun for me, right? But I learned a tremendous amount about how roofs are actually put together. What basic materials are used to make a roof? Plywood. Plywood, some tar paper, right? And some concrete shingles. That's about it. There's not a lot on your roof. And it's really, every time I think about a roof, I go, wait, there's only like that much stuff that's keeping the rain and the elements and my heat in, It's not a whole lot of roof. Roofs are pretty small and pretty simple. But they're basically, yeah, there's not a whole lot up there. Trust me, there's not. But I think a good practice to get into as 3D modelers is to put ourselves in the mindset of someone who's responsible for actually creating these shapes, right? If I was building a house, what materials would a roofer have at their disposal? Well, they're going to have some plywood. They're going to have some 2x4s or some 2x6s, right? They're going to have some tar paper, some shingles. We can take some inspiration from there, and that's going to help us figure out what simple shapes to start with, okay? So I think what I'm going to start off with, believe it or not, is just a cube, right? Just a rectangle. So let's make the house. Actually, you know what? Yeah. Oops. I'm going to center my house along the x-axis. There we go. That way my roof line is generally in the center. So let's just make a little rectangle. I'm going to super exaggerate this just so we can see it. Roofs aren't actually that thick, but we'll make it pretty big so it's really easy. Your roof is not 10 inches thick. It really isn't. It's like 6. But I'm just going to start with a really long, skinny rectangle. Now, what I'm trying to create here and trying to figure out is the pitch of the roof, okay? Because all roofs have a small angle on top of them for the water to run off, okay? I don't know what that angle is. There's actually some math, the rise and run, that determines how, the pitch of the roof. We're not going to go into that today because we're artists, not engineers, okay? But I do want to start prototyping what this roof is going to look like. Maybe something right about there. Yeah, I like that. Now, in my imagination, I'm picturing it also going down this other way. We'll get to that in a minute, okay? So I'm only doing 1/2 of the roof. Something like that. There we go. I'm liking that. That's looking pretty good, okay? This is 1/2 of the roof, okay? What I don't like is this. Look at the overhang way over here. Roofs don't have that kind of overhang. The eaves of your roof, they're not that big. There's a little bit of an overhang outside, over your walls, but not that big. Not that big, That's like this long of an overhang. It should be probably about like that, 18 to 24 inches. So I need to move that edge up the slope of my roof, right? How am I going to do that without screwing up the angle of the roof? Could use the work plane as a great way of doing it. There's another way of doing it. Yeah, if you use the move tool on the surface, it's like, I can move it, right? But the moment I start moving it, I change the angle of the roof, which is not what I want, right? I move it along the X, I change the angle of the roof. I move it along the Y, naturally I change the angle of my roof, okay? I want to see if I can move that edge along the slope of that polygon without changing the slope of the polygon. We're going to use the move tool for this operation. And before I change my settings a little bit here, I want you to notice the orientation of the tool handles. Right now, they're aligned globally to the XYZ axis. Y is up, X is left and right. It matches our compass in the lower right of our viewport perfectly, okay? Well, I don't want my tool handles to match the global orientation of the XYZ axis. I want it to match the local orientation of that polygon, okay? So we're going to change our action centers, much like we did last week, or maybe the week before when we were doing our radial sweeping in our radial array, okay? But this time we're not going to use the origin action center like we did last time. We're going to change our action center to selection. Now it's going to look at the selected component and its orientation inside of our 3D scene to help and determine the placement of our tool handles. Watch what happens to my move tool handles when I change it to selection. Okay? Now, check it out. I can move that shape or move that edge up and down along its local x-axis, and it's not changing the pitch or the angle of my roof. Okay? So now I can just kind of spot check it and go, yep, that's kind of right about what I want. A little bit of runoff for the water. I don't want the water pooling next to the foot of my house. This is going to be good. At the very least, Pat's modeling hut is not going to flood. Okay, all right, so this is looking pretty good. I'm happy with that. Let's change our action center back to none and start looking at how we can make a mirrored copy of this shape across the x-axis. Okay, this is where our snapping system really comes back into play. It's going to be a nice extension for us because I want to slice this object perfectly right down the middle of the x-axis, all right, so I can mirror this shape across the x-axis. If you noticed earlier when we were talking about our snapping system, of course we can snap to vertexes. It's great. We can also snap to the grid. Okay? Maybe if we turn off vertex snap and enable our grid snap, let's turn on our snapping engine. Watch what happens now when I just simply do a slice. See the little blue cross there? That's the snap highlight. That's telling me where my tool handle would be placed if I were to left click in that moment. So now I can just left click and drag down. The tool handles are automatically snapping to the grid, so I know I have great accuracy and confidence that I'm slicing this object perfectly down the middle of the x-axis, okay? Which is cool. I want to drop the tool, turn off my snapping engine, and I no longer need this big section over here. Just delete it. So there's 1/2 of my roof. Now I need another copy. I need to copy across over here. Using our snapping system again, Intel, we can get this result pretty quickly. Okay. Since I snapped my slice to the grid, I know with great confidence that that vert and that vert are both chilling right there at the middle of the x-axis. Okay. I want to mirror this. Let's turn our snap system back on. Much like radial array, where we click determines where the center of the mirror is going to happen. It's going to snap right there on the grid. That's what I get. I get a mirrored copy of the geometry. Now, before I drop the tool, there are a couple properties that I want you guys to look at. Merge verts is one that often gets turned on and off in and out of all of our open labs. Okay? If merge verts is on, it's going to weld both those pieces together. Okay? Which in our case is exactly what we want, right? But sometimes people turn it off. Just know that that's an option. Drop the tool, disable my snap, and now I got my roof. Ta-da! Ish. Getting there, right? I'm getting there. Okay? It's not much of a roof. So how am I going to make it into a 3D roof? Extrude, bevel. I think extrude will work. Bevel is going to always leave one side open. Extrude will make it a true 3D shape. There we go. I'm going to give it an awesome overhang because I want to have a party porch. Right? Got a little barbecue, some lawn chairs. Right? Yeah. I got to have a door back here. Currently, there's no way to get to my hangout. But the creation of the roof solves one problem, but it creates another. Right now, what is the screaming problem for my little modeling hut? Yeah, I got the world's best air conditioning system right now, right? It's open aired, right? I need to start closing the walls up a little bit and making this a true closed shape, okay? So this presents a problem for us. This presents a big time problem for us. How can we change the slope of all of these polygons that represent the top of my walls to match the slope of the roof? I don't know it numerically, okay? I can't go in and do this. This would be impossible. I can't like grab that edge and go, okay, and there, grab, oops, yeah, I already messed up. Can't grab these. I mean, I can do it, but now we're twisting these polygons on the top. They're never going to look right. It's taking a tremendous amount of effort to get there, right? This is a pretty simple shape, but in a more complex layout, this could take forever, okay? And it's never going to be right, so this is not a good strategy. Given what we've talked about today, what could be a strategy? Booleans. You got it. Let's do it. I'm going to take my roof, and I'm going to cut and paste it from mesh item that it's currently on to this one. Now, I don't need my windows anymore, so I'm just going to delete them and return to my walls. There we go. So my roof's on a new layer. I am going to grab these top polygons and simply just move them up like that, way above my roof line. Okay? Now I run the Boolean just like I did earlier. Geometry, Boolean, solid drill. I'll change my operation to slice. Aha, look at that. And it sliced my walls just wonderfully. Okay. Now there's some junk in here that we don't need. I'm going to delete the top portion of my house. Just hold down the Shift key and up arrow. Delete all those polygons. They're not needed. And now my walls perfectly match the slope of my roof. Okay? Let's get everything back into one layer by cutting and pasting. And there she blows. Starting to look pretty great. Starting to look pretty good. Okay? Working. This is the power of Booleans, taking one piece of geometry and using it to slice and edit another piece of geometry.
So how did you close the roof again?
Yeah, let's do it one more time. So I'm starting to split everything into its own layer, right? I put my roof in one layer, in my cutter layer. There it is. And then I just grab the tops of my walls and I move them super high, higher than they probably need to be for this example, higher than the roof, okay? Everything above the roof line is going to get deleted anyway, so it doesn't matter how far it goes. Okay. With the cutter mesh in the background, we can run the Boolean solid drill. I really like this slice operation. It's my favorite, right? I really like it. However, there are some other good ones in here. I'll let you explore those. Slice does an excellent, excellent job. It puts me in the driver's seat as to the next step. And now my walls are going to get sliced to match the pattern of the Boolean, of the roof. I apologize. Now, I don't need all of this jazz up in here, so I'm just simply going to delete it. Now I'm on my way. Now there's a couple, let's get everything back onto its own mesh item. All right. Now there's a couple cleanup things in here that we need to do. I want you to focus your energy on this wall in particular. I'm going to hide my roof. If you look very carefully, and I recognize that may be a challenge to see on this projector in here, but does it look like it's being shaded kind of oddly? Yeah, it does, right? You can see they got this kind of odd gradient going down, and then there's kind of this line here. This is a gigantic n-gon, okay? The computer doesn't know how to shade this surface at the moment, right? If we turn on the visibility of our verts, there we go. Check it out. When I did the Boolean, it added some verts for me. That's always going to happen, okay? But at the end of the day, we need to go in and start resolving some of these n-gons and getting them back into quads, okay? How could I do this real fast for this polygon out here? Edge slice. Edge slice is going to be my jam. Keyboard shortcut for edge slice is C. You can also find the edge slice tool inside of your mesh edit. There it is right there, mesh edit collection of tools. I'm going to start my slice in the middle of the edge, and then left click and drag that yellow dot to where I want my slice to begin. And then go down here to the bottom and slice that way. Now I could slice all the way around, okay, like this, and then connect back up on its friend on that side. That works just fine. And now that shading error that we saw in the front is gone. These are n-gons over here as well, but because they're flat planar surfaces, we don't seem to get too many shading errors. Yeah, all this stuff looks generally okay, and I'm pretty happy. All right, life is good. I'm pretty stoked about this. This is working out pretty well. However, when we start looking at houses, we need a little bit more info, especially on something like a window, to really give us the compelling detail to fool our imagination into believing this is a real house. You're going to do some research on what homes and businesses look like, and you're going to find that there's trim. You can see it in the windows in here. When you build a house, does anyone have a little bit of exposure to construction industry? I have some, okay? When you build a house, you actually just make openings for windows and doors, okay? And then we go in and we physically place the window in the opening, okay? So imagine that this is the stud wall opening that the framers created for us, okay? And then the window subcontractor comes in with a pre-built window and they stick it in that opening, right? And then after the window's in there and they make it all level and square inside the box, you can see it really easy on the windows over by my office. Once it's in the box, then they go back and they add trim pieces that go around the outside of the opening to cover up all the unfinished edges and to make it look pretty. Okay? That's really the function of trim. It's just to cover unfinished edges. That's it. That's why it's called trim, I guess, right? So I want to do something similar. Yep. And put spray foam and all sorts of stuff in there to make it waterproof and insulated. They got some. It can get pretty fancy. And yeah, I know, right? Yeah, trust me, I know. Yeah, windows are crazy expensive. They shouldn't be crazy expensive, but they are. Houses are money pits. Yeah, they're money pits. So I want to do something very similar because this isn't enough detail in my little window here to give me a good result. I want to create an actual window and then some actual trim that's going to go around the window and then duplicate that trim, 5 or 6 times quickly, okay? It's not about working hard, it's about working smart. Maybe employ some snapping to get the job done quickly, and we'll call it a day. Yeah?
So this would be for
Yeah.
Not just building the picture. Because remember, you were saying when you're just building the picture, it's only what your eyes are seeing.
I think this is good information to put in there. Yeah, because your eye is going to see the window trim around the house, around the windows, around the doorways. I wouldn't put much more information than what I'm going to do in there. I had a student, this was more than a couple years ago now. At the end of this very assignment, the student waved me over to their machine and they said, Pat, look at my doorknob, right? And they had spent hours working on the front door of their house. And to their credit, he or she, I don't remember who it was now, they did a wonderful job, okay? When the render camera was right next to the door, it was beautiful. It was a great model. But then I said, okay, show me the render of your finished project. And of course, they went to a render shot that looked honestly not too dissimilar to this, okay? And they didn't see it at all, right? And it was just hours and hours and hours of energy on their front door. And what that translated into was basically just a cube and a cylinder to make the doorknob itself. I mean, I felt so bad for them, but it looks great, right? So we got to be careful. We got to pick and choose. We don't want to put a ton of geometric detail in something we're not going to see. But windows and trims, if you look at this picture here, you can see the windows. You can see the trim. That's good stuff to add into our stuff. Yeah?
So again, yeah, it's me with the roof, but when I do this Boolean, it slices the roof, not the top of the wall.
So go back to your wall layer, right? You got to have the wall layer selected, okay? Okay, so let me go back in time a couple steps here, because the setup for our Booleans is important. Okay, all right. So if you look at the way that I have mine set up, I got the walls on one mesh item, and the cutting geometry on another. Okay, great. So when you run the Boolean, it's going to look at all the stuff that's unselected or on different mesh items and use that to slice our stuff, right? Inside of your Boolean tools, you want to make sure that the driver mesh is the background. Okay, that could be the problem as well. It's the default, but you know.
I mean, I might show you after because it's all set up that way.
Okay.
It's just not doing it right. See, so here's the cutters.
Okay.
basically.
Yep.
Okay, and here's the regular
Yep.
mesh.
Let's do it.
All right, so we'll go to Boolean, background, and then it just
Ah,
doesn't
the
slice the
visibility of the other mesh is off. There it is. Now it will work. Yep. Okay. Background means in this context unselected. In the MODO verse, whatever item is selected is in the foreground. Anything that's unselected, as the cutter mesh is, that's a background mesh item. We want to be very careful, right? If we had 8 meshes on here, right? And if the visibility for all 8 of those meshes was enabled, all 8 of those meshes would be slicing whatever we have selected. And the visibility is the selection system. Let me show you what I'm talking about, just so everyone's on the same page. That's a good question, okay? I'm going to create a new mesh item. And on that mesh item, I'm just going to create a cylinder, and I'll have that cylinder go through the back of my house, right? And let's do, yeah, okay. This kind of isn't going to work because I've already sliced everything, but, so this is the circle. If I wanted to have the walls be cut by this mesh item, I want to make sure that that one's turned off. Because whatever item is visible and unselected is going to be evaluated by the Boolean tool. So the circle, if I was to run the Boolean operator at the moment, see how it's not visible? Now, I don't have anything, like I said, this is it's already been sliced, so it's kind of ripping a hole in the space-time continuum. But that circle wasn't sliced into my walls. Okay? Good question. Okay. Let's keep cruising here. So windows. Let's do it over here because there's 2 right next to each other. There's 3 right next to each other. So I want to create a window and then some trim quickly around that. What basic shape is a window? It's a rectangle, right? It's just a glorified rectangle, right? We already have a rectangle, so let's think outside the box here. I want to have my window be perfectly centered inside of the box for my window, okay? So maybe I just use loop slice. Loop slice with the count of 2. A mode is symmetry. And now I'm just going to play around and kind of experiment with the size of my window, maybe something like that. There we go. Oops, excuse me. So those polygons in there are going to be a representation of the width, the total width of my window. Now what happens if I just bevel them up? Bevel them up by, I don't know, 2.5 inches. Okay, now I know that the width of that polygon is 2.5 inches. Okay, could do it again if I'd like. You can even use the bevel tool. Maybe if you want this dimension in here. So from that vert to that vert, if you want it to be a defined dimension, let's just make it 2 inches or 2.5 inches so it's really easy to see. Okay. Boom. There it is, window. Okay. Now I need some glass. Glass is almost always held onto. Glass is kind of like sandwiched between some pieces. Okay. I want to make it 1 inch. There we go. And now we're starting to create the illusion of a compelling little window. It's simple. I'm keeping it simple. Okay. Some people go really nerdy on it. Now, we also needed some geometry in here for an actual window itself, so we can get reflections and what have you. So this is Pat's trick. I've been doing this for years. It's a great trick for windows. Just do loop slice, count of 1, mode of uniform. So it puts a loop right smack dab in the middle, right down there. Okay. Notice that I have that loop selected. Just hit the P key. Now it actually filled in the polygon, but it's facing the wrong way. It's facing on the inside. Okay. I want to hit the F key to flip it. There we go. Now I got the glass, the window frame itself, and the window box all kind of set and ready to go. Now I have a whole bunch of windows that are the exact same size. If I remember correctly, this window, and this window, and this one over here, they're identical to each other. Okay? I now have a prototype that I can use for all those other windows. Okay? Before I get into copying all the windows themselves, let's just add some trim in here. And this is where our snapping system really becomes a benefit for us. Okay? Because I already have verts inside of my scene that define the boundary of my window. I can snap to those with my vertex snapping system. If we creatively start to apply maybe like the wall mode and pen tool, check it out. It gets really fast, really quickly. Okay? I'm going to turn on my snapping engine and just ensure that I'm in fact snapping to verts, not the grid. And now, once again, I'm going to activate the pen tool. Can't live without the pen tool anymore. And I don't want my walls, let's make them 2 inches. Most trim's about 2 inches going around the outside of a window. Okay? Check this action out. Now I can just snap, 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 and snap. Now I don't want it to be closed, and I don't want to merge the verts. Okay? So I'm going to turn that option off. Yeah, so I'm snap. Yeah, yep. I'm using the wall mode set to 2 inches paired with my vertex snapping, and now I got quick trim. Let's drop the tool, bevel it out by, let's see, probably 1.5 inches is not right, but I'll leave it at 1.5 inches just so we can see it. Oops, excuse me. I hit the wrong button. Let's try that again. There we go. That's separate from the rest of the house. Yep, looking good. Now we need to have the little rail at the bottom, which is bigger than the actual trim. But once again, I'm just going to use my vertex snapping system to get what I'm after. I could use wall mode if I wanted to, right? However, but everything gets paired to the vertex snapping system, even our cube tools. So now I can just simply create a cube whose dimensions are 4 feet by, I don't know, let's make it 2 inches. That's pretty good. I had a hard time selecting it. Let's bevel it out. I don't know what the dimensions are going to be. It's going to be a little bit bigger. And I also need to scale that entire shape, because if you ever notice that they kind of stick out a little bit like that, that's cool. Oops, looks like I messed up a little bit, but that's okay. Because with my snapping engine, I can just use the move tool and snap. There we go. Up like that. Everything works, or the snap is a global snap. So the move tool, the scale tool, the rotate tool also leverage the power of the snapping system if we wanted to. Now let me blow your brains even more a little bit, because this really kind of shows the power of the MODO modeling tool set, especially when paired to the snapping engine. I've made one window, okay? I got 3 more of these things to make. It's not about working hard, it's about working smart. But what if I start to make copies of all this stuff and then utilize the power of my snaps to put them in all the windows quickly, okay? First things first, I gotta go grab all this stuff. I'm gonna cut and paste. I'm gonna grab that and grab that. Okay, so in every sense, that's what I have left. Okay, I want to hold down the Control and Shift key to make a duplicate of it. So now I got another one. But now I need to figure out where this window goes in the box over here. And this is where it hurts your brain a little bit. But that inside corner of my window should go right there inside the box. Well, while the snap is on and my action centers are off, I can snap my tool handles to any vert on my scene, right? And with my tool handles snapped to that vert, I simply can drag over. And I want to see how my cursor's gone to, let's see if I can do it. See how my cursor's gone to kind of a purpley little cross? Any vert that I put that cross on, the tool handles are going to go to that vert. They're going to snap right to it. There it is. There's one, done. And it's perfectly in there. Need a couple more. Make a copy. This one I have to rotate. Hold down Control to rotate it 90 degrees. Let's do the exact same thing again. Fire off the Move tool. With my snap enabled, I'm going to put it in that corner because that one I can see real carefully or real easily. I'll put my cursor, see my cursor above over here? Boom, it just snaps. So now I know that it's positioned correctly along the x-axis. We'll do the same thing for the z-axis. There's my cursor. There it is. It's snapped. And now it's in. It takes some practice getting used to this. It looks like I didn't snap it far enough. I snapped at the wrong point. Let's try this again. Oh, it messed up for a second. It's deciding not to work at the end of the class today. There it goes. Oh, I got the wrong one for the depth. There it is. Mission accomplished. Okay. Got one more. You can. Yep. You can. Absolutely. It doesn't have to be all one piece. You're never going to get any sort of light leakage through the polygons if you're careful with the placement of the geometry in relationship to the walls. So it's a great, especially when the render is back, you know, this kind of view. I'm running out of time, and I think I've blown your minds enough today. But there it is. That's starting to look pretty great. Let's put it in camera for a second, see how we're doing. Yeah, and Pat's modeling hut starting to look pretty decent. So your job this week is to do some architectural modeling. Keep it basic. Houses are really nothing more than a whole series of squares stacked on top of each other. Where it gets complex is when we start adding in, roof lines and things like that. Go back to the live stream. Look at the way I put this stuff together. The Boolean tools are great. They're really quite helpful, okay? Be mindful of what you're slicing, and the Boolean tools won't get out of control, because sometimes they can get out of control if you're not careful, okay? To help you out, here's what I want you to do before you begin. I want you to do some research. I want you to look at some houses and start collecting some photographs and even maybe some architectural blueprints that you could use to help in the creation of your house. I'm forcing my hand on this one. Research is a big part of everything that we do in the 3D modeling world. We all think we know what a house looks like until we have to make a 3D model of it, right? And then we stand there and we scratch our heads for a long time going, man, what does a door look like? How big is the door? How big is a window? What's the depth of all of this, right? It gets challenging really fast if we don't have these additional pieces of reference in tow. So I want you to start your process by going in and doing some reference collection, just by getting some images that will serve both as inspiration, but also as a visual guide as to the language of a house, okay? Start looking at some pictures. Now I want you to go in and I want you to find at least 10 of these things, okay? At least 10. You can do this pretty quickly. If you can find 10 images of one house, even better, right? Shoot, if it's easier for you, this is a great idea. If you're going to do your own house, go take 10 pictures of your house and use that as a guide to help you model, right? When you're doing this at 3 a.m., you just look at a picture real easily instead of having to go outside with a flashlight and say, where's my door in relationship to the window next to the front? Things like that, right? It really does serve as a fantastic guide to help us down this path. Can anyone guess what house this is? It's the Haunted Mansion from Disneyland, right? Which I've always wanted to make a 3D model of because I think it's a really cool kind of iconic house. I love all the ironwork on the front and stuff. It's pretty great. It's pretty great. So when you're done with this, just make a zipped archive. Do you guys know how to zip up some files? Most of you guys know how to do this already. On the Mac, it's really easy. Let me show you how to do it. It's equally as easy on a Windows machine. So this is a project file that I was working with this morning for my advanced class. Okay. Now on the Mac, it's really as simple as right-clicking on the file and choosing compress. Okay. And that's going to create a zipped archive of whatever it is that I have selected. For the context of this lab, I would put all of my reference images in a folder and then right-click on that folder and compress it. Boom, upload it to Canvas. You're done. Okay. This is the easiest 25 points you'll earn all semester long, but I need you to do it, okay? And there's no expectation that you actually build the house you collect reference for.
We can go to a different house than the one that we were researching.
Yeah, you could. You could. It is, yeah. I think that's a bad idea, but you certainly could do it. Hannah, you had a question. I want to make sure that it's answered before we head out.
I just wanted to know, I thought of another good haunted house that would be really kind of fun to do.
Uh-huh.
The Winchester House.
The Winchester House, the Winchester Mystery House. Have you been down there?
No, but I want to.
Yeah, I've never been down there myself. Is it cool?
It's really cool. I loved it.
Yeah, awesome. I love my crazies, and from what I understand, the person that made that house was a legit crazy, so I think that's awesome.
He thought that the ghosts of the guns that they had made killed all the ancestors, and that's why she continued to make the house.
Uh-huh.
So she could confuse the spirits.
It's awesome.
Oh, yeah,
So good.
There's like winding corridors that don't go anywhere. I heard this somewhere. I don't know where I heard it.
Yeah, the Winchester Mystery House.
There's stairways that don't go anywhere.
Yeah.
There's a floor that just has a giant glass on the bottom of it, so she was able to watch all her servants feed her food. Put her food, so she wasn't worried that her servants would poison her food.
There you go. I love it. Some legit crazy. I love it. Okay. So when you're done collecting your reference for this week, remember, we're just making the model. Okay? We're not going to do the textures. If you wanted to go in and start plugging in simple materials to start colorizing things, I think that's fine. I think it's a great place to begin. Start, tagging things, creating some simple materials. I think that's fine, but I really want you to focus on the entirety of the model itself. If we return to the assignment sheet, there's a couple things in here that I want you to add to your model because it's not just a house, okay? It's a little bit more than the house, okay? Landscape. Okay? Simple little environment goes a long, long way. Okay? It provides a great, almost instantaneous understanding of scale. You put a car in the driveway, you understand how big the house is. You put a bush in the front yard, you understand how big the house is. You put a small little fence around your house, you understand how big the house is. Without these extra little geometric cues, the audience is going to be left wondering, how big or small is this thing? It also starts to create a really good, pretty picture, because we want to start to fill in the blanks surrounding our house. It's not just the house. In the architectural visualization world, we're trying to create kind of an understanding of the entire environment that this house is placed in.
It's sort of like the houses, the new animated one.
Uh-huh.
Those look actually really,
Yeah,
really well.
they're really good. So for trees and bushes, I want you to go in to put trees and bushes. I think modeling trees and bushes is a monumental waste of time. It really is. You know how hard it is to model a realistic tree quickly? It's pretty tough. Quick. You can't do it quick. It's going to take you a couple hours. And even then, the results are going to be pretty poor, right? Modeling trees is not easy. Modeling a rock, do you really want to model a rock? No one wants to model a rock. No one gets into this business, I want to be a rock maker. No one says that. I've been doing this for 20 years. I've not met a single person that's like, you know what, I want to model rocks all day, right? No one does that, right? So here's my suggestion. MODO actually comes with a whole bunch of really great tree and bush models already ready for you, okay? So you can be found inside of your mesh preset library. And this is the only time in this class, this is the 3D modeling class, that I'm going to allow you to add some stuff from the mesh preset library. Because the focus of this assignment is just to make a house, not to make a car or a bush or whatever. We're just making a house. There are no house presets in the mesh preset library. If you hit the F6 key on your keyboard, you open up the preset library. There's a whole bunch of really great stuff in here. Shoot, here's a dog for Pat's modeling hut. Okay? You double click on the mesh presets, and they get loaded in at the origin of your scene. There's my dog. I don't actually have a dog. I do like dogs. My wife really wants to get a miniature pig. Like every week, she's like, hey, can we get a miniature pig? And it's like, no, I don't want to get a miniature pig. So we're not going to get a miniature pig. Anyways, okay. So the mesh preset library allows you to very quickly insert geometry into your scene. Now, double-clicking on any one of the presets is automatically going to place it at the origin of the scene. If you look over here inside the meshes section, I'm in the animals section, but if you keep cruising down, and I think it's in organic. Yeah. Plants. You're welcome. Rocks. Trees. Okay. You're welcome. We'll talk about how to put leaves on some of the trees next week. Okay. But simply double-clicking on one. This one's kind of big. There it is. It's chilling. I don't want a tree in my house, so I'm going to move it. Although some houses have trees on the inside, and I think that's pretty neat. I've always wanted to have a tree like growing up at the center of my house. There it is.
You should get a treehouse.
I should get a tree house. I should make my own tree house.
You should call it the Treehouse Mastery.
Right? Yeah, I've seen that television show, right? But adding these simple little things in here go a long, long way, including the dog and my stumpy-looking tree, to help adding some extra details that brings our house into reality. It brings it to life a little bit. Okay, so use the tree presets, the bush presets, some of the rocks. Shoot, you can even put a dog in there if you'd like. I don't care. Have fun with it. So you hit the F6 key. It brings open your preset library. Okay, F6. Let's see. I don't think it's in the file menu. I think it's under the, where is it?
Is it assets or?
I actually don't remember where it is inside of here. Might be under items. I don't know. F6 is the keyboard shortcut for it, though. That's how you get to it. So don't forget F6.
I was just asking in case I do forget.
Don't forget.
You find like the horse.
Dog.
Or the dog, yeah.
It's in the preset library. Yeah, it's in the animals section.
Okay, my stuff is included.
Okay. It may be, yeah.
The same presets.
Yep.
I mean, I have the same MODO, but why have 12 points?
Add the presets here.
Oh, they have them here?
Yeah, they have them on these machines and the ones in the lot in the design lab.
I'll do that.
Yep. So you're not just doing a house, you're also doing a simple environment for your house as well. Okay? Because keep in mind, we're in the picture business, right? We're here to make pretty pictures. These extra little things help us create pretty pictures pretty fast. Sound good?
Yep.
Good luck. May the force be with you. I'll see you guys next week.